Welcome back to my channel. In today's video, we're going to explore how to tell whether the information we see in the media is trustworthy or false. This is an important skill, especially because it's part of one of the Level 1 NCEA Science Achievement Standards here in New Zealand. In today's world, we're bombarded with information. News articles, TikTok videos, blogs, and even scientific-looking graphics on Instagram. But how do you know what's real science and what is not? Some publications present information as science, but their claims might be based on partial information, misinformation, or even disinformation. That is where your science literacy comes in. Science isn't just a bunch of facts. It's a way of thinking. Scientific ideas are developed through critical and creative thinking, backed by evidence, and shaped by discussion, testing, and review. Before we accept any claim as scientific, we must ask the following questions. Where did the data come from? Was it peer-reviewed? Is the source credible? When you read a publication, whether it's online or in print, pay close attention to how science is being presented. Let's look at this in detail. 1. Scientific vocabulary. Does the publication use science terms correctly, or are they just trying to sound smart? Words like energy, chemical, or toxin can be misused to make something seem more scientific than it is. 2. Graphics and visuals. Graphs, charts, and images should clearly represent the data. But sometimes, visuals are misleading, like cutting off an axis to exaggerate trends, or using unrelated images to sway opinion. 3. Conventions of science writing. Scientific publications usually follow specific structures, clear definitions, explanations based on evidence, and referencing studies. If these are missing or vague, it's a red flag. Every piece of writing has a purpose, and that purpose shapes how information is represented. Ask yourself, is the author trying to inform, persuade, or sell something? Are they affiliated with a particular group, brand, or ideology? Could their purpose influence how they present scientific data? Now, it's your turn to be the scientist. Use your science understanding to critique the claim. Look at the claim. Does it match the data? Does it ignore counter-evidence? Is the language emotional or objective? At higher levels of achievement, you'll also be able to explain how scientific language and conventions can be used, not just to explain ideas, but to manipulate or misrepresent them. In a world flooded with information, you have the power to think like a scientist. When you recognize how science works, and how it can be misrepresented, you're less likely to be fooled by flashy presentations. Remember, science is about evidence, not opinion. Communication should be clear and honest. And you have the tools to critique and question every claim you come across. Thanks for watching this video on science claims. More videos on this topic are coming soon. So stay tuned and don't forget to subscribe to the channel. Happy learning!